Okay, today I'm going to redo the video on complete the square method to find the vertex and the zeros, and also ultimately the vertex form and the factored form of a quadratic function in standard form. I will do two examples. Example 1 that has a leading coefficient of 1, and example 2 that has a leading coefficient other than 1. Although I would say it's not my favorite method to use when you have a leading coefficient other than 1. We still need to cover it. Okay, so we'll start quickly with this one. There's a few things that if you watch videos from different people on YouTube, you may see some different steps that are taken a little bit differently. Over the years, I just found some steps easier to make it easier for myself. But again, if you watch other videos, you could do the way you want as long as you show your work. Okay, my step number 1. The first thing I usually do, even though it's not because I'm solving right away, I do like to make my equation equal to 0 because I will, my step number 2, I usually bring my C on the other side, okay? So it makes it easier when I'm trying to complete my square. There's a step to me that really makes a huge difference if I bring my C on the other side of the equal sign using algebraic manipulation, obviously, okay? You will see why in a little while. Okay, so then I'm left with x squared minus 10x. Okay, you're going to see something throughout this video. I like to color code everything that's going to be in red are values that are not part of my original equation, okay? Anything in red will be values that I add in order to create my perfect square on the left-hand side of the equal sign, okay? Remember that in algebra, the golden rule of algebra is whatever I add or subtract or multiply or divide onto the left side of the equal sign, I have to do on the right side. I shouldn't say all those basic arithmetic operations because it also applies to everything else. Square rooting, squaring, cubing, cube root, all of that, okay? So whatever I do onto one side, I have to do on the other side. Okay. So now we are at the complete the square part of this this process. We want to change this equation into a perfect square because remember, let's backtrack a little bit. What does our vertex form look like? It looks like this. A, which in this case is 1, right? Minus h squared plus k. So we're trying to get this part right now of the equation done. So in order to do that, we have to take our left-hand side of the equation and transform it into a perfect square. And obviously, to do that, I need to add a value that's not there originally. It's fine, as long as I make sure that I add it on both sides. So, this is here, okay? This is what's going on here. I'm gonna put my x squared here because I know that's where it belongs. So I know this is x and x. Now I'm gonna take my middle term here, negative 10x, and I will split it in half. I will split it in half because if I want to create a perfect square, it has to be negative 10 divided by 2, which turns out to be negative 5 and negative 5. And yes, if you have an odd number there, let's say the linear term would be negative 7x. Yes, I would have to have on the side of my boxes negative 3.5 and negative 3.5. It's okay. It's fine. We can deal with very easy decimals, okay? But for the sake of this, I just left it as an even number. But know that when you practice, you get some practice, you may come across some linear terms that are odd. Totally fine. So if I complete my box here, I have my negative 5x and negative 5x. I haven't added anything yet. I haven't added anything yet because my x squared, my negative 5x plus negative 5x, this part here is part of my original equation. Now what I'm trying to add, I'm going to complete my square My last square here, if I do this, has to become a positive 25. You see, that's the number that I'm adding on both sides to turn the left hand side of the equal side into a perfect square. So my question mark becomes a plus 25 on this side here. And remember what I said, my golden rule of algebra, whatever I do onto one side, I have to add it also on the other side. Why am I doing this? Is because I want to turn this expression here, right, the one we talked about, I want this to remain, to be changed into a perfect square with an expression factored form, right, like this. So x squared minus 10x plus 25 is the same thing as x minus 5 squared. Let's look at this again. Okay, I don't know why I have a Star Wars lifesaver, but whatever. Lightsaber. So this expression here, x squared minus 10x plus 25 is the same as x minus 5 squared. Look, I have it here. I have it here on the side of my box. Good. So now I need to compute the right-hand side of my equation. What is 25 minus 12 or negative 12 plus 25? I'm left with 13, positive 13. Now I'm not quite done. If I want my vertex form, you see my vertex form here at the top. My vertex form has the following structure. It has, remember that my leading coefficient is 1, so that's why there's nothing. And I need to bring the 13 on this side, negative 13. Okay, so my equation in vertex form, y equals, I'm just going to bring that a little smaller so I can use the rest of the page. Y equals, I'm going to use a different color. Y equals x minus 5 squared minus 13. And if you look on the graph, now let's identify our vertex. Our vertex is, remember we talked about that many times in our chapter 3 as well. Our vertex is 5 comma negative 13. Now the wonderful thing about complete the square method is you can also find the zeros, the x-intercept. Because you have this form here, I'm going to erase this so it makes more sense. And what I usually do is I get this form here, okay? Oops, I'm going to use a different color. I'm going to use white here. We're going to use this equation because we already have the 13 on the other side. We already made the y equals 0 and we already passed the 13. So let's backtrack a few steps and use this one in order to solve. So we have x minus 5 squared equals 13. Remember that finding the zeros is like finding the x-intercepts, meaning we are solving for x. And since we usually have two x-intercepts, we should have x equals something and another x equals something. We should have two values there, two x values there. So guys, please do not distribute here, the left-hand side, this side here. Do not distribute this. You already have a square there. So what are we going to do? We are going to square root both sides. Square root both sides. So you're left with x minus 5 equals root 13. But you also have x minus 5 equals negative root 13. Remember that. We square root. Anytime you solve, right, in a section, and you have to, sorry, I don't know why it's all crooked like this. Anytime you have to square root part of a process of solving, you have a positive and a negative root. So you end up here with x equals root 13 plus 5 and x equals negative root 13 plus 5, which can also be written as x equals plus or minus root 13 plus 5. Remember, you are not gonna punch this in the calculator, although you can totally do it, right? You can, one of the x-intercepts will be, you can literally punch in root 13 plus 5 in the calculator. That would give you a decimal, and negative root 13 plus 5, and it would give you another decimal. But this is not what we're looking for. We don't have a calculator in this part of the test, so we're not gonna punch it in. We just know my two x-intercepts are those two decimal values, okay? If you want to pause and graph this on your Desmos, check it out. you should see that it works. Now we're going to do example 2. We're not going to spend too much time on that because it's just the only difference is the kind of there's one little extra step that we need to take. So I'll try not to take too long because I know this video is turning to be a little long. So it's okay. We have our example 2 here. First, but the one thing is, remember, the first step is still the same. We will make my expression equals 0. And I'm still going to bring my 2 on the other side. And I'm going to be left with my 3x squared plus 9. In this case, I'm not going to place my plus question mark yet because there is something I need to do. I need to remove my scale factor. I need to factor out my scale factor to make it easier for myself. So I'm going to factor out my 3 and I'm going to be left with x squared plus 3x. Then now I can add my question mark inside here. But remember that the 3, you see I'm going to close the parentheses after it. So whatever question mark I'm going to find is affected by my 3. Okay? So before I can add it on this side here, I have to multiply it by 3. Remember that the scale factor does not affect the x position, the x coordinate of the vertex, and the x-intercepts. It affects, though, the y coordinate of the vertex. That's why I will have to multiply by 3 at the end. Whatever I find there, I will have to multiply it. So let's do this quickly. The middle part, I'm not going to take too much time on this because this you have done before. So we're going to use the box on the side to complete the square. My x squared goes here, x and x. And now you see I have an example where I have to split my 3 in half. So it's 1.5 and 1.5, which gives me 1.5x and 1.5x. Remember, it has to be split in 2 because if you don't split it in 2, then you don't end up with a perfect square. Okay, so, and what goes in red? So you see I changed my pen. We have here 1.5 times 1.5. Sorry, something weird happened. Okay, so we get our 2.25 here. Whoops, 2.25. So my question mark here ends up being plus 2.25. So let me rewrite this so it looks better. So it makes a little bit more sense. 3x squared plus 3x plus, change color, 2.25. Okay, whoops. Let's try to use the same structure. Okay, close parentheses equals 2. I'm going to make this smaller. Okay. Now, before I add my 2.25 on the other side, I do have to multiply it by 3. So we get 2.25 times 3 will be 6.75, right? So we know we have to add 6.75 on this side. So now we can rewrite our expression 3 here, open parentheses, our side of the box, x plus 1.5 squared equals, and here we have our 2 plus, so we end up 8.75. Which, if we rewrite it in vertex form, it gives us y equals 3x plus 1.5 squared minus 8.75. Our vertex will be negative 1.5 comma negative 8.75. Okay, and our vertex form is here. And if you want to solve, this one is a little trickier, not because, it looks great, it's not that, but you probably will want to punch it in the calculator because ultimately you're going to get something like here. You need to take this, remember, you need to take this form here. You would divide by 3 on both sides, divide by 3. Then you would square root, right? Square root both sides, square root. And subtract 1.5 on both sides. Remember, you have a plus and minus. So it kind of looks crazy. Remember, we're not going to have to do much of these that have a leading coefficient, but it is something that you need to know how to work. But ultimately, when we put everything together, there is a much easier way to find the vertex if there is a leading coefficient, okay? So on the test, you're mostly going to be asked to find your vertex using completing the square method when your leading coefficient is 1. Okay, so try to remember that. So don't panic too much about this method. It's very similar, but the difference is this part here, where when you complete the square, that 2.25 needs to be multiplied by the leading coefficient before you add it on this side. So it's really the big difference of what's going on here when your leading coefficient isn't 1. Okay, so I hope this helps.